That was also a cast, by the way.
How do you derive the confinement parameter 10 to the 36 particles per cube?
We've simply taken the estimated lifetimes of beta palladium hydride that are in all the metallurgical texts, and assuming a density that we would obtain by having one hydrogen atom per palladium atom in a volume that size, and multiplying them times each other.
The plot that contained the Lawson criterion that you presented showed a horizontal line of break even. Is the scaling of that just simply based on the observations you had apparent break even?
Yes.
Or it's not a theoretical?
No, no. That comes from the calculations in the first table.
Is there a short-term correlation between the current flow and heat production rate?
Short-term?
Yeah, what's the time constant for changes in heat rate if you change the current?
Well, the thermal relaxation time of the dewars we've been using are on the order of, I think, 1,800 seconds. So any change, you would have to wait that long before you could determine what the new cooling constant was. So the measurements are simply slow. Apparently it goes up, at least within that time frame, within hours. I mean, we could do that for large electrodes. We could do that experiment in a test tube instead of a dewar, so that we would have a much quicker cell cooling constant, or much more rapid attainment of equilibrium, and make those measurements. And we are going to do that with the larger electrodes. We don't have to have such accuracy with high heat.
Suppose everything works great the way you think and hope that it does. What do you see as the critical things that would need to be done between here and getting practical power output?
Well, just getting a database and find out what these electrodes act like as a function of geometry and everything as you scale them up. We have to scale it up and see. It's going to be I don't see any problem, but we just need to see what the radiation looks like and what the thermal balances are as you start to make the devices larger.
You mentioned that there's a possibility of the nuclear excited state of helium-4, which, if I recall correctly, has about 24 MeV of energy over the ground state. Do you have any mechanism how this may be given up? Is it going to be given up as gamma, or do you think?
They think the energy is dissipated to the massive electron that's binding them, that's shielding them.
Do you think it could yield phonons in the lattice and not a bunch of gammas?
That's clearly a possibility. Because of the dielectric constant measurements that have been made, there is good evidence for a larger mass electron. So I think when the paper comes down, take a look and see. They make a pretty convincing argument.
Have you looked for X-rays?
No. It's a good point.
And likewise, have you found any evidence of higher energy gammas?
No, we've looked for 22 MeV gammas and have not seen them.
Do you have any data, or can you postulate what the effects of highly elevated or depressed temperatures would be on the reaction?
Only that on this last electrode that we have used, which is a 4 millimeter diameter that had been clipped down so we could get higher current densities, the temperature changes then are quite sudden and are quite spectacular. It goes to a certain level, hangs there for 2 or 3 days, and then makes a sudden jump of several degrees, not just tenths of a degree or hundredths of a degree, but several degrees. And it did this 3 subsequent times over about an 8-day period, and finally evaporated all the water out and open circuited. So we've now started that. That happened about 3 weeks ago. We've now started that cell back up. So obviously at higher temperatures there are some erratic effects, which we don't understand yet.
You mentioned the possibility of clusters of neurons in your March.
Again, this just gets you back to the multiple site occupancy of deuterium in the lattice.
One furthest back.
Can you exclude the possibility of fusions being initiated by adventitious radiation?
No, we cannot.
If the tritium and neutron production is down by a factor of 10 to the 9, is the crucial issue to demonstrate a nuclear reaction the quantitative production of helium-4 consistent with the amount of heat you've seen? You feel that's the crucial measurement?
I think that's a crucial measurement, yeah.